Hi, welcome to an exciting video on the laws of logarithms. It's so exciting, logs got cut in half here, I don't know why. But let's continue. So we're going to take some notes. We're going to do lots of examples in this one, so be ready for that. Again, here we go. We're going for the laws of logarithms. We can begin with the logarithm of a product. So let's say you have the logarithm of some base, and then there's a product. So logarithm of a product. That can be expanded into two logs with the same base as the original, and the addition of those two logs. So that product inside the log here turned into two logs with the addition or sum of log of the first one and log of the second. Let's see if you can apply that to these problems. So take these two log statements and express them as a single logarithm. In other words, combine them into one log. Well, that one you can see is a sum, and they do have the same base, therefore those two things can become a product within one log. Second one, so do the opposite. Here you have to combine 2 to 1. Here, take this one and expand it into two logs. And that becomes log of 2 and plus log of y, because that product turns into the addition of those two logs. We don't see any number there. When you see no number, we assume it is a base of 10. Okay, so prove it. If you're interested in how where that rule comes from, take a look at this. We have a log. We're going to set log of base a of x equal to m, and we're going to set log base a of y equal to n. So by definition, if we change this to exponential form, we know that x equals a to the m power, and we know that y equals a to the n power. Okay, so let's begin with this. We have a log statement with a product, and we're going to rewrite it like this, because we just found out that if we let x, let's see, x equals this, y equals that, based on those two logs. So those two can change to these two statements. And now that can expand, those can combine like this, right? M plus n. And we also know that when you have a log of some base and then the same base here in exponent, that can simplify into just m plus n. But going back to the beginning, we know m equals this and n equals this, therefore this statement is equal to this statement. So we've proven that that is equal to that. Take another look at that. There's a couple of little twists and turns in there that make it not so obvious, but take a look if you're interested in the proof there. Okay, and with that idea, can you follow the exact same process and try to prove the second rule that we kind of discovered in class? That is, if we have a division within one log, it can turn into a two log statement with a subtraction. So that's exactly like this one here, except we have, instead of multiplication, we have division, and instead of addition here at the end, we have subtraction. So try. I think it's a really good process to go through. Try the same process to prove that. All right, I hope you tried that and you were successful. Let's look at the next rule then. So logarithm of a quotient. In this case, when we have a log with a base and there's a quotient of terms there, we can rewrite it as two logs. We can expand it with the same base as the original and subtraction of those two logs. And then the two things that were a quotient or division turned into a subtraction of those two logs there. Okay, first example. So take this, express that as a single logarithm. Well, that single log will be this. Again, we see subtraction of two logs with the same base. Therefore, we turn into one log with that base and then a quotient of those two things. This one, do the opposite. We see one log, can you expand it into a larger expression with two logs? In this case, there was our quotient, so we have a subtraction of those two logs with the same base, and we have the 15 here and the 7y here. Great. By the way, we can go even further. And we should have gone further. We see that there's actually two things here, just like we had two things here. We have now two things here, but this is a product, and a product tells us we will add those. However, since we have minus this entire log, even if you turn this into log base 9 of 7 plus log base 9 of y, since we have a minus sign in front of that entire statement, both of those turn into negative. Another way to look at that is, in the numerator we have 15, so there's our 15. In the denominator, so we're dividing by both this and this, so division of both of those, so minus that one and minus that one, because they both began in the denominator there. All right, So next, we just a recap. So there's the two rules we've looked at, the quotient rule here, the product rule here. And now let's look at a little bit more of a proof. So let's say we had this log statement. It can turn into exponential right here. And let's say we begin with something like this. We have a log with an exponent here, and we rewrite this part here based on our statement here as a to the m. So now we have a to the m to the p. Well, you know that those two exponents by rule of exponents will combine like this, multiplication. And now again, the rule where we have the base and the common base of the log and exponent, that turns into mp. But we know from the beginning that m equals this thing here, so that m is replaced by the log, and we have this. So we've proven that when you have a log, and within the log there's a term with an exponent, that exponent can just simply drop in front of the entire log. So there it is right here. This is a really important rule of logs. So it looks like this. And we're going to summarize it again here. Again, logarithm of a power. So when you have a log statement with an exponent, the exponent can be written outside or inside there. It means the same thing. And that can turn into this. That exponent drops in front of the log. Really important rule. So here's two. Can you take this one and can you condense it? In other words, can you make it smaller? So I see this multiplier in front of the log. What can I do? In this case, so that multiplier, again, like you can do the reverse here. So there's a multiplier, it can jump up there, right? It can jump up and become the exponent. So that half jumped up, became the exponent of that. However, anything to the half exponent really means the square root of that thing. And the square root of 9 and x squared is 3x. So take another look at that, make sure you understand those steps. And second one, in this case, expand. We have this log statement and it says expand. So it means make it bigger. Can you make it bigger? So take a look at that. We have that root 7 there. What can you do? In this case, our root 7th root is the same as a 1 over 7 power. And now by our rule here, we can take that exponent and drop it in front. So we put it there. So we've expanded that log statement slightly. Okay, so let's use these rules. In this one, try a and b first. Can you write these as a single logarithm? Well, check your work there. This one was addition, so it turned to a product, which can combine to that. And this one was subtraction, which turned into a quotient, and there it is. Now try c and d. Okay, let's check our work here. In C, okay, it's important to know, and this is a key thing here, maybe this is a little tricky. 1, okay, when we have a 1, that can always be written like a log statement like this. Log of some base and the same number here, because you're thinking 7 to what power makes 7? Well, 7 to the first power, so this means that this is all equal to 1. In this case, we chose 7 because we're trying to make the same base. We could have written log base 9 of 9, log base 10 of 10, log base 11 of 11, but we chose the same base. So now that we have the same base, combine those. I see subtraction turns into quotient in one log. Second one, I see that 2 in front, so that's definitely going to jump up and become the exponent of the 5. There it is. And that 2, again, by the same thing we're looking at here, in this case, it's not a 1, it's a 2, so a little trickier, but basically we're trying to make the same base, so 10, and you're thinking, okay, 10 to what power? This is the power, 10 to the second power, well, that's 10 to the second power here, right? Because 10 to the second power equals 10 to the second power. So a little bit tricky, asking you to really take a deeper look at your understanding of how logs work. So make sure you look at that 1 and 2 again and understand how we came up with those. This simplifies to this to that. Now we have addition, same base, so we can multiply by a product rule and get this. So those two definitely stepped up the game there a little bit. Study C and D again to make sure you're good with those. Okay, here's some more extra practice. Expand fully. First one, well, we have, first you take care of the division. I see division here, so I wrote it as subtraction of those two things. Each of these has a lot more going on, so this one can break up into 3, and by product rule we have addition. Here's x squared, and then this one we can break up into 2 parts as well, 5 and y cubed. So here's 5y cubed, and again I have the minus sign because that minus will apply to both those things. If we break this up into addition, there's a minus sign that applies to both, and again they both appeared in the denominator, so therefore they both have minus signs here. And now I see an extra thing. Each of these has an exponent, so I'm going to bring that 2 to the front here, and I'm going to bring that 3 to the front here as well. This next one here, give it a try. And look at this one. We have we can split it into two logs. We have a product here, so sum of the log with a squared and sum of the log with b to the half, because the root is a half power. And then that half, that exponent can drop to the front, as with the 2, it can drop to the front as well. So I've done everything I can to expand those fully. Okay, next one. Now take these and express them as a single logarithm. Okay, first one, we can see that 3 jumped up to that exponent. Then I see subtraction here, addition here. So addition means all those things that are positive are going to be in the numerator, and all the things that are negative logs are going to be in the denominator. So the 7 and the 10 cubed are here, and that 5 is here. That can be simplified further maybe, but I'm just going to leave it like that. We could have multiplied and divided by 5, but let's leave it. Next one, we see I took that half and put that to the exponent here. And then I combined some things. Oh no, I guess I did this first. The half power of that means the square root of 36, which is 6. And now again, I see addition here, subtraction here. So these end up being the products on top here, and this ends up being the quotient in a single log. 5 times 6 divided by 10, that's 30 divided by 10 is 3. All right, here's a few more. If we have x equals this and y equals that, can you write these as expressions in terms of x and y? So in other words, turn this into something that has only x and y in it. This one might take a moment to think about. Okay, so first of all, we can take a look at 12, and 12 is actually 2 times 6. And we know log of 2 and log of 6 here. So that breaks up into log of 2 plus log of 6 by the product rule, and therefore each of those pieces is equal to x and y, so x plus y. In the second one, we have 3. 3 is actually the division of 6 and 2. So we can rewrite it like that. And we know, again, we know log of 6, we know log of 2. We know that that's going to be y and that's going to be an x. But first, by quotient rule, we split that up into subtraction. And again, this is now x, and this is y. So we can write it like, y and x, so y minus x. The last one, 48 is 8 times 6. Therefore, we can split that into log of 8 plus log of 6. 8 taken further, because it's not one of the two we were given, 8 taken further is 2 to the third power. And then that 3 can drop in front. So now we do have that log 2 and log 6 like we were given in the beginning here. And we can say 3x plus y. Those, if that's the first time you're seeing something like that, those are kind of tricky. But I think once you get a hang of those, you start thinking, okay, how can I make that number into the two numbers I see here? So that's the goal here. Okay, so using that same kind of logic here, can you do that with this one? I have a log statement, and I have a, b, and c given here. Can you rewrite this in terms of a, b, and c? Well, that I broke up into this. So we have our quotient. It's this thing here, and then these two are both denominators, so they're both minus minus here. Okay, I'm going to take all the exponents here. I'm going to drop them to the front, so the half goes here, the 2 goes here, and the 3 goes here. And now those 3 match what we're given here, so we can rewrite it as half a minus 2b minus 3c. Okay, one last one in that kind of problem, so let's try this one. And check your work here. Okay, so we went through the laws of logs, started with some basic problems, and then moved into these ones, which are a little more tricky. But again, once you get the hang of it, you're on it. You can do this thing. So you can do it. We'll see you in class to continue this lesson. I hope you enjoyed learning the laws of logs.